Across chronic disease, one thing keeps showing up: cells losing energy. And that failure isn't random. It's flipped on by a switch, a survival program that's built into our biology. And the most consistent way that that switch is activated is through fructose metabolism. Now, this video is a map of this series, a guided tour of the big picture that we're going to be unpacking, chapter by chapter. And so each section I mention today is going to become its own set of videos. If something sparks your interest, just know that we'll dive much deeper later. So how does it work? When fructose enters a cell, it's rapidly phosphorylated by fructokinase. That means ATP drops, mitochondria downshift, nitric oxide fails, uric acid rises, cravings intensify, fat is conserved. But this isn't damage per se. This is conservation mode, because short bursts of this protect us. But in today's environment, this switch never turns off. So chapter 1 will unpack the biochemistry of how this switch works. When energy-starved cells start accumulating, they become fragile. Now, a few don't matter, but across tissues, fragility starts scaling, organs weaken, systems fail. And that's why diabetes, hypertension, fatty liver, and even Alzheimer's seem to cluster together, because they're not separate epidemics. They're different faces of the same upstream problem: fragile, energy-starved cells. And so chapter 2 will explore how fragile cells become fragile systems. And here's the kicker: fructose isn't just something we eat. Our bodies can make it internally through the polyol pathway. What are the triggers? See if these sound familiar. High glucose, salt, dehydration, alcohol, low oxygen, stress. This explains why simply cutting sugar so often fails, because this pathway has redundant triggers built right into it. And so chapter 3 will cover endogenous fructose production, the body's hidden sugar factory. Now let's talk about fat. Fructose metabolism is not a mistake. It's a program. In times of abundance, it stored calories for famine. In times of scarcity, it lowered metabolism to conserve energy. So today, that same program ensures that we eat more, we store more, and we burn less. And that's why fat gain, fatigue, and cravings so often appear together. Chapter 4 then reframes obesity as the intended outcome of this conservation switch. But this isn't just theory. Nature itself has evidence. Bears fatten on berries before hibernation. Birds and desert mammals conserve water through uric acid. Naked mole rats survive without oxygen using fructose. Hummingbirds flip daily between sugar-driven diabetes and fat-burning recovery. Even fruit itself carries the logic. Unripe fruit protects. Ripe fruit triggers storage. And fermented fruit signals urgency. And history tells the same story. Sugar was once rare, confined to elites, but industrialization, supermarkets, and of course high fructose corn syrup made it a constant in our diet, and disease rates rose in parallel. And so chapter 5 will walk through nature's playbook, the fruit paradox, and this historical record. When this switch stays stuck on, 4 major categories of disease emerge. Metabolic dysfunction, shown with obesity, diabetes, fatty liver, gout. Cardiovascular disease develops. We know it as hypertension, vascular fragility, heart attacks. Neurodegeneration, shown with brain fog, depression, Alzheimer's, all these different ways that the brain runs on fragile energy. And cancer, tumors that thrive in the glycolytic environment that fructose actually creates. And so chapter 6 will examine each of these major categories of disease in turn and how they relate to fructose. So what do we do? For decades, advice is focused on restriction. Eat less, cut sugar, exercise more. But restriction fights biology, and biology will always win. So the better strategy is modulation. turning down the switch itself. Lifestyle measures help: hydration, salt balance, glucose control, oxygenation, but the most direct target is the enzyme fructokinase. We know this from a rare condition called essential fructosuria. People born without fructokinase excrete fructose harmlessly and don't develop metabolic disease. And this points to fructokinase as the master switch, and it even opens the door to interventions, from pharmaceuticals to nutraceuticals, like luteolin and tart cherry, that directly modulate this pathway. And so Chapter 7 will explore these intervention strategies. So here's the big picture. Fragile cells become fragile systems, and fructose metabolism is the upstream switch. By modulating that switch, we can move beyond just symptom management and towards restoring energy and clarity and resilience. This is the Metabolic Energy Failure Framework, the Fructose Model, the map for everything that follows. So let's get into the details.